welcome to another session with my Tangerine Tiger. Yes, I've been pimping it up unnecessarily, but hey, I thought it deserved it. Somebody described this as a pretty woman in an orange dress. Okay, everybody has their taste in women. So today, while we're waiting for pieces to be manufactured so we can get on with the guts of the machine, we're going to start working around the machine and doing a few other bits and pieces. Now, for instance, there are pieces in the electrical cabinet that we don't need. Let's just have a look. This is the high voltage power supply for the tube, which is no longer in there. So we can immediately take that out. This is mains power, which we don't need. Well, we do need the mains power, but not for this power supply. So where are we connected to? Let's just work out that one. That one's probably the water. It's a rather old style of power supply. I think that's probably a K40 power supply, because that link there shouldn't be there. Well, it should be there for that particular power supply, but that's not the standard power supply. So glad we're getting rid of this. This is CN5, and that's water protect, which we don't need because we've got no water on this machine. So we can afford to take that out and lose the water protect. So we really don't need any of those cables. I think the only one that we shall need out of here is ground and power width modulation, which is pin number 3. So we're only going to want pin 1 and 3 to control this RF unit. So we've got a big space here which could be used So I don't think it's a sensible move to try and squeeze that in there when we've got plenty of room up the top. Well, we've got lots of things that we can put in this space here. Two things in particular. One of them is a timing relay, a delay timer, which will turn the fan off 10 or 15 seconds after the cycle is finished, so we don't keep running the fan. Very annoying. We've also got this kit here from Cloudray, which is the Ultimate Air Assist kit, which I will show you how to install on this machine. A couple of years ago I bought this very cheap little board, which is a delay relay board. It's got 4 little relays on there which carry something like about, I think, 10 amps. We could delay the turning off of the fan. If we really wanted to, we could delay the turning off of the air assist pump. I thought this was a superb piece of kit. 4-time delay relays for £12, and yet I'm paying something like about £50 for that unit there. Now, I've got to be very careful when I say that I bought myself a piece of rubbish, because I didn't. It does exactly what it says on the tin, but not what I expected it to do. So therefore, this is a perfectly good piece of kit for the right application. Let me just explain to you where I went wrong with this piece of kit, and where you might be tempted to go wrong as well if you decide to buy this as a delay relay. What I've got on the other machine is this. I've got, when the laser cycle starts, when the program starts, it automatically starts the fan. Okay, so the fan actual extraction might be 4 or 5 seconds after the start of the cycle, but that's usually not a problem, because very quickly with the large fan the suction catches up and you draw all the fumes away. But what we don't really want is it running forever and ever in between cycles. So I've got the other one set so that after the cycle stops, the fan stops as well, but there's maybe a 10 or 15 second delay. It's a variable time that I can set on this time delay relay. Not so with this little circuit board. It does exactly what it says on the tin. When you trigger it, and any on signal triggers the circuits. Mode 1, it switches on and off and on and off and on and off and on and off for as long as you want. Now, these other cycles can also switch on and off and on and off like this, cyclically. And you can count, there are modes which allow you to count the number of cycles that it turns on and off. You can turn the cycling completely off, as I've done here, or you can leave it on permanently. So there are 3 modes of cycling: none, permanently, or a counted number of cycles. Excellent. You can see here, look, we've got relay coil off, on, off, on, off, on. Those are the start conditions. So you can either choose to have the power on the coil to start with or off. I mean, the instructions say just on or off, but because this is a changeover relay, you've got no idea what on or off means. So I've just defined it against the relay coil itself. So when the coil is not energized, it's low, and when it's energized, it's high. Okay, so we can start with the energized coil high, so we can get a delay off for X amount of seconds, minutes, hours, I think up to about 100 hours. And then we turn it on, and that's it. So we just get one delay cycle, and that's all we get. So each one of these is a delay cycle. This one starts with it off, and then it turns on. Then after a period of time it turns off and remains off. So as you can see, each one of these is only triggering a cycle at the beginning of the laser switch on cycle, and we want the delay triggered on the off signal. It is possible to use this device with a separate relay, which we are going to do anyway for the air assist kit. But I decided that it was much easier to just have a completely separate timer rather than go through the complication of linking up relays, because I've got to put a 24 volt supply on this as well. I decided to bypass that unit. Now the other thing that we're going to be doing is getting rid of these horrible multifunction sockets. I've had no end of complaints about those, and at the end of the day, people would much prefer to have IEC sockets like that. I mean, we've got a nice IEC socket there which is fused, if I can see correctly. Yeah, I think it's fused. I'm sure if I look in there. Come on, out you come. There we go. China Blue didn't have anything this sophisticated, but at least this one has got a fuse in it, and there is, just in case you do blow the fuse, there is a spare fuse tucked in the back there. All right. So let's just have a look to see what this fuse actually is, what rating it is. I'm expecting it to be at least 10 amps. So I'm going to remove this panel and replace it with my own switch panel. So I'm just going to take the earth off of here. And I'm half expecting to not be surprised. Let me explain. I'm not surprised. That's an absolutely useless earth, isn't it? It's not earth at all. Now this chassis might be powder coated, which is in itself insulation. It should be connected to bare metal. It's not. The earth is not connected to bare metal. Technically, parts of this frame could easily go live if something goes wrong. So we're going to have to fix that problem and put a different earth system on. So I think our first task is to decide what we're going to do about these switches, what's going to operate what, and what's going to happen on this panel here. Now, when you're running this machine on 110 volts, which quite a lot of Americans do, there is a wire that goes to this switch, which is probably not suitable for taking huge amounts of current. It's a piece of 10 amp rated cable, which is what this emergency stop switch is. But of course, 10 amps is fine for all the places in the world that use 220 volts, because this machine doesn't take more than probably 5 or 6 amps. But if you decide to plug the fan into one of these sockets here, the fan in itself could take 2 or 3 amps at 220 volts, which means it's going to take 6 amps at 110 volts. You've almost used up all of your capacity on this switch before you start putting any other current through it. So these switches, I've had many, more than that number of reports about these switches melting from guys in the States that happen to be using 110 volts. The standard US domestic mains is 110, but you know, you can get 220 volts if you've got a workshop. So what I would prefer to do is to keep all the external devices, particularly the air pump and the fan, on a completely separate mains supply that does not run through this emergency stop switch. So I've made myself a new mains input plate here, and basically what we've got is a single control for the machine power in, and that machine power will power what's in here, and then we've got a separate ancillary power in with a fuse on it, the same as this one. And these two here, one is for the air compressor, which will be running instantly on and off with the cycle, and this one, which is the extraction fan, which will come on instantly with the cycle, but there will be delay off on this socket, so we can put 5, 10, 15, 20 second delay on the fan. Well, we're gradually just taking things off this machine that we don't need, like we don't need that. We don't need these water pipes, and I always thought it was a silly idea to put the air on the door, so I've got to get the air assist system in here somewhere. We've got to strip quite lots of bits of cable out. For instance, this one here, that's the earth cable that came back from the end of the tube, the cathode end of the tube, and these are the two cables here which go to the LED strip light that's in the front there. Now I'm still debating whether I should use that, maybe use this thing, or at least the power to it, and put the strip light underneath the gantry. So quite a few little decisions to be made, which I'll sort out as I go. When you get your air assist kit, you'll find that it comes in pieces like this. Now, the valve was marked up P, R and A for the 3 ports, but when you look at the drawing, you'll find that it's marked up 1, 3 and 2. Now, you probably can work it out for yourself, but 2 as A, 1 as P and 3 as R. We're going to put the mains air in at A, and we're going to put that straightforward simple fitting in there. Okay, now we'll just screw it in finger tight for the moment. Into P, which is on the other side, we're going to put this so-called running T. So that screws into there. Right, so we've got a straight through run here now, which is what happens when the valve is on. The air goes straight through there. Now when the valve is off, like it is at the moment, the air is connected between here and here. And so into there, what we're going to do is put the remaining fitting, which is this one, an elbow with a restrictor on it. You can wind them in a couple of turns, but don't wind them in really hard, because they don't have to be completely leak proof, because we're only using 4 psi air. Just do them up so that they're snug. You're given a piece of pipe here, but really you don't need much of that pipe at all. What you've got to do, you've got to join this here, push that in, and it's got to loop over, and it's got to go into there, and it's as simple as that. So we just cut off a piece about that long and plug that into there. Okay, so now we've got all this tube here to play with. We can plug it in the back end there. Right, and we can now move this where we want inside the machine. So that's my connection to the head, and this is my connection to the door, or wherever I'm going to connect it, up here somewhere. That gives me lots of cable to decide where I can put this, and I'm going to take that right across to the front of the machine. I think we've got plenty of blue tube there, so we can afford to have this probably somewhere like this. I've got to sit it flat because there are screws on the back there, and I've got a little template that I've made with 2 holes in it, which hopefully match the holes in the bottom there, which they do. Okay, so I'll just keep that the same way, and that's got to go on the outside, so I'll just roughly position this where I want it, about there. And I'll stuck my template on the outside of the machine here, roughly where I need it. There's our 2 pilot holes. There we go. 2 holes. So that's the air assist valve fitted into the machine. we'll take the cap off, ready to wire it up. Now these are funny little caps, these things. You have to take the screws right out. So we should be able to take that valve cap off, because there is actually an additional vent valve on the top here as well, which we don't use. Just take that, be careful, don't use that spring washer. So there's the cap, there's a spring washer, and then you can take that off to make it easy to connect the wiring to. Now it's taking very little load, so I've got some fairly lightweight 3-core cable here. Now there's no plus and minus, so we can just connect the 2 wires. So we just put the 2 wires in the top 2 connections. Now the one thing we've got to do is to put the cables over that central pip there, like that, because that's where our screw fits. And that's as complicated as that, I'm afraid, except I've put it on the wrong way round. Look, that's the top, this is the bottom, and it won't fit over the bottom, I don't think, so I've got to reverse the cap. So now we don't have to worry about that cable going past that pip. Now we can put this back on. It doesn't matter which way it goes. If it's convenient to have it upwards, then, or that way, it really doesn't matter. I think it's convenient to have it this way, because then I'm going to bring my cable down here. So we put our spring washer back on there, and then screw the cap back on. And it very conveniently at the other end of the machine, we have a hole to get into the cabinet. Sadly, I don't have a piece of DIN rail. The great advantage of having a little workshop like this with a few basic tools in, I can make my own DIN rail, because I thought you might be interested how efficient you can be with very crude equipment. So here I've got a piece of 3mm thick material, which I'm going to put onto a steel plate. I'm going to put a piece of copper on top, and then I'm going to put another piece of 3mm material on top of the copper, like that. Okay, so we've got 2 pieces of 3mm material sitting on top of the copper, delicately balanced there and lined up fairly well by eye. Then we're going to put a 3rd piece of metal on top and make a sandwich. Then we're going to offer the sandwich up into the fly press, and we're going to give it a gentle kiss. And there's our DIN rail. Well, not quite, it's a little bit wide at the moment, but hey, that's going to be easy enough to put that in my guillotine and just trim it down. And here we go. I think we've got it nearly right, so we'll just check. All I've got to do is put a couple of holes in it to fix it to the back plate, and we're ready to rock and roll. So I might want those power cables a little bit longer, so we'll just take the end one out, which is the ground return from the tube. I can pull that one out now. Something else jointed in with it as well. Crude, isn't it? I think we'll sort that out later. Let's pull that out completely and work out what we're going to do with that, because that's for a bit of 240 volt stuff, that's not very good, is it? I think it's just a piece of PVC, to be honest. Now, the numbers that are on this relay do not agree with the numbers on this diagram here, which is a little bit confusing, to say the least. 1 and 5. What I'm going to do is to give myself a quick drawing of what they look like. That will enable me to quickly see what's going on. So I have a couple of clamps for the DIN rail as well, just end clamps. the clamps don't really fit the din rail because the din rail is not deep enough. Oh, I suppose I could grind the bottoms off a little bit, couldn't I? Yeah, I'll do that. I think we might make them fit now. Just about, there we go, they now fit. Just a little bit of persuasion with a grinder. There we go, that's nice and solid now. They're not going to come off. This was the mains to the power supply, and I want to pick that up to send it to the mains to my power supply. On the surface the wiring looks quite neat, but when you dig a little bit deeper it's a bit of a dog's breakfast. A couple of hours have passed, and things can move on quite quickly in my world. And here we have something that I hope I'm going to be able to squeeze in here. It may well be a little bit of a struggle. Now, I already knew that I was likely to have to take this corner off, but how much I don't know. We can't wiggle that piece of metal in there because the bracket that holds it is in the way. So what I'm going to do is I'm going to drill a couple of holes in here to fix the bracket back on, and then I'm going to grind the welds to take the bracket off. I've got to get in there to grind the welds off. Just shows you how difficult welds are to get off, doesn't it? We've got the bracket off. Now can we wiggle this thing in? That's the question, because we couldn't before. Oh, 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 oh. Oh, ho, ho. Almost. Maybe just a little bit here. Just a little bit. I've just made these little spacing pillars, which will actually be screwed through the base plate there, or the sliding plate. I just want to see roughly where they go. In fact, what I should be doing, I should be using the back face of this as the reference when I slide it backwards and forwards. Now when I mount the mirror on here, it's quite difficult to get to that adjusting screw under there so that I can set the mirror onto beam centre. So what I've got to do is to make sure I put a hexagon head under there so I can get to it with a spanner. Now ultimately I've got to put a hole through here, but I don't know where, and I've got no idea what size, but I'm not going to make the hole much bigger than the beam. So instead of having something like an inch diameter or inch and a half diameter hole like they normally have, I'm going to eventually put a target on there, fire the beam at it, and then I'm going to drill a hole maybe 6 or 8 millimeters diameter for the beam to go through. So we've got a drawing here for the centres of the holes, which I'm going to make a jig out of a piece of acrylic and spot those dimensions through onto here for the pillars. And then here we've got a sketch of all the dimensions that we found earlier, the relationship between the rails, the top of the bracket. Then we've got this angle here, which is this piece of material here. There's a 2 millimeter piece of material here, which is the piece that's mounted on. This is the mounting face of the RF unit. And this is the ideal height to get the centre of the mirror lined up with the centre of the beam. At the moment, the mirror is sitting at 20 millimeters. When we come to set things up, I may have to put a packing piece under the mirror. But this is a very, very small beam, and it probably doesn't need to be on the true centre of the mirror. Well, wherever look, there's little teeny weeny problems. There's another one just here. There's a big lump of weld here where they've joined up across here. It's all been sanded off there because they didn't know that I wanted to fit something tightly under there. not very level, is it? Look, it runs from nothing to about 2 millimeters there. Right, so with those pillars underneath there, we've got a nice air gap. Air going in the end here between the pillars, so everything's nice and vented. And we shall probably take this end panel out, and I might see if I can fit a fan in there as well. So there it is, mounted on its channel, ready to adjust backwards and forwards. So the 48 volts from there goes into there, so that's no big deal. We've got a cable that comes from here, which is the PWM, that can run along the back here and go down to the electrical cabinet. Well, I think that's about as far as we're going to go today. Next time, it really depends how long the laser cutter is going to take producing my parts. I was hoping that they might be available by the end of this week, but yeah, it's got a very busy time on at the moment, and my pieces are in a fairly long queue. Early next week I hope that we should be in a position to finish off the internals of the machine. In the meantime, we can do this, and we can sort the wiring out. So yeah, there's still a lot to do, but we can see an end to it. So thanks for your patience and time, and I'll catch up with you in the next session.